Welcome to lesson 8 of the Swift fundamentals. In this lesson, as I said, you will learn the fundamental difference between classes and structs by understanding reference type versus value type. So let's begin. Welcome to Learn Swift with Bob. Today in this lesson, we're going to talk about the difference between classes and structs. And this is $1 million question. A lot of people have no idea why we use classes over the other. Well, in this lesson, we'll talk about everything. So what are the difference between besides inheritance? We know that structs do not provide inheritance as far as in Swift, but what else? Okay, and when to use structs over classes. Before I talk about some theoretical aspect, I think it's better to go with some practical examples how they are different in behavior when it comes to creating an object. Okay, so first of all, I'm gonna design a class. You'll see a distinct behavior differences in behavior, and I'm gonna find out slowly. You'll get the difference later. So we have a class called human class, contains a name property, and you have an initialized method. Okay, so let's create an instance. I'll call human class object and contains the human call name Bob. Okay, everything should make sense by now, very easy. And now when you access this property name, you will have Bob right there. Come on, that's good. It's not showing, so let's try to do something like this. Human class object name. Hopefully it shows up on the right side. Come on, yeah, right there, it's Bob. So this is what I'm gonna do. Right now, I'm gonna create a constant call. Let's call it var new human object, and what's gonna do is we're gonna assign with the class object right there, which we created right here. Okay, come on, and then here's the magic. This is not really the magic. We are gonna change the property of new human class object. Yeah, let's try to do that. New human class object dot name. Let's change to Bobby. Okay, so it sounds good. So right now, new human class object dot name is Bobby, but what happens to human class object? Do you think the name will be changed to Bobby or simply Bob? Well, let's find out. Human class object dot name. Now let's take a look at this. Bobby. Oh, interesting. You made some sort of a copy, or we call it quote unquote copy from the human class object. But now when you make a change to the property of the copied version, it has an impact to the original version. Okay, that makes sense. All right, that is a behavior we've seen in classes. Well, let's find out what happens with structs. Okay, we're going to design the exactly identical stuff. We have a human struct called name, initializer method, same name. All right, so we're going to create a human class object right there. Okay, human struct object, human struct. By the way, for those who are confused, sometimes for structs only, you don't need to create this init method. So, in Swift, you have to initialize it, right? So when you create this human struct object, now it just automatically asks you to enter what's the name. Okay, it doesn't happen for classes, they only happen for struct. If you're using classes, you have to have this init method. But it's optional for you to have this init method for classes. But what it allows you to do, you can do something like this, print created. And so what happens is when you create an object with struct, if you wanted some extra implementation, yeah, you need to use init, but you don't have to. So let's leave it like, actually, for the sake of similarity, just leave it like this. Okay, all good. So now let's create an object and then something that has reference to the original object. So new class object is equal struct assigned from struct object. Okay, exactly the identical stuff we did so far right there above. Okay, so now let's take a look at it. I'm gonna change the new struct object name to Bobby, just like what we did above here. New human class object name Bobby, and also now let's take a look at whether the name of the original object has been changed or not. Well, let's take a look at it. Boom, Bob. It has not been changed, and that is a fundamental difference in behavior. But why is that so? Well, if you know the reason, you can just skip this part Actually, it's a good idea for you to listen anyway. So here's why. I made this a little simple diagram for you guys. Forget about value type versus reference type. You guys probably heard about it, but don't worry about it. I'm gonna explain from the start. So for struct, when you do this kind of assignment going on right here, what's happening is new struct object is simply copy and paste a different object. Okay, if you never program in C or C++, but anything has with memory management, it may not make sense too much. But what's happening is when you do this kind of new struct object equals struct object, you're simply copying the value and assigning to new struct object. Okay, they're two separate entities. So as you can see, there are two separate entities. Struct object is number one, struct object number two. So anything you have changed to struct object does not have any impact to struct object on the top. Okay, vice versa. We call this value type. If you know memory management, we're going to talk a lot more in later chapters, but simply they have different memory address. If you don't know about memory address, that's fine. They just create two different objects. That's what it means what happens when you do this. But when it comes to classes, it's a little different. Well, when you do this human class with when you create an object with human class with Bob, what happens is you're creating a class called object in the memory called only one memory address human class, and contains a single object is being created. And when you have this assignment, you're not simply human class object does not own anything. It has a reference to this object that is floating around the RAM, the memory. Okay, and what happens is when you do this, you have a reference. This thing has a reference, the memory reference. If you don't know about if when I say memory, if you don't understand what I mean by its memory, that's okay. What I'm saying is, when you create this constant or variable, it just has a reference to the human class. It's like it doesn't really own anything, but it has like a navigation towards. It's like it has a address that point out that this object in memory in RAM. Okay, but when you do this part, on the other hand, what's happening is you're not literally copying and pasting. You're not. I say copy paste just for to simplify the concept, but you're not copying paste for when it comes to classes and struct. You're literally just sharing the same memory address. You're sharing the same. Hey, this thing exists. Hey, point at this one. So point at this one. So when it comes new human class object, also just pointing at this reference, and when you need to use some of the properties, you're just simply hit look up and right there and use it. For value type, however, struct object contains one variable, one constant contains its own object, and they're interacting with its own. Okay, hope that makes sense. So what you call value type, because you're simply copying and copying the value. Reference type, because you're simply looking up the answer key on the back of your textbook. Okay, hope that makes sense. That is the difference when it comes to struct and classes. Okay, so but there's one more difference in mutability. It may not make sense what I mean by mutability. Well, let me explain to you. So let's create a dummy class called Bob class. It contains a property called Bob. We don't have to, since it's initialized, we don't have to use the initialize method. Okay, let's create this Bob class. Let's create a class object and assign to this constant, and contains Bob B. But here's the thing, if you notice or not, take a look at this is a constant, this is not a variable, right? But you are able to change the property of Bob class object to Bobby, even though it is made with constant. That is weird, right? Well, let's find out if that's the case. Let's find out. Right there. Come on, Xcode. Right there, it has been changed to Bobby. How is this possible? Well, before I explain, let's compare with the struct. So what I'm going to do is, let's call it immutable struct, contains Bob struct with a variable name Bob. And what's going to happen is you're simply going to create this constant as well, Bob struct equals Bob struct. And let's change the Bob struct name to Bobby. Do you think it's going to work? It's not going to work. Why is that so? Hey, why not? Why don't you? It is a let constant. You're not allowed to change the property if it's a constant. So you got to make this into a var. But why is that so? Well, here's the interesting part. When it comes to classes, what's happening is you're not literally changing the object that is assigned. Well, human class object, for example, this is Bob class constant, is not really changing what's within within itself. It's actually changing what's in the memory in the cloud. Okay, so whenever you do this, Bob name class Bob, you're not changing what's with Bob class. You're changing what's with Bob class object that's floating around, the only single object in the air in memory. Okay, so that is the difference. But when it comes to struct, however, each constant, each variable contains its own implementation, its own memory. So what happens is you're not allowed to change the value. So, but you're able to change the constant that's floating around it because they share. All right, it's able to do that. But when it comes to struct, you cannot, because they don't share. Just contain. They're like kind of like pertain into a box. You're not allowed to do that with struct. Okay. So, and finally, the second question: when to use structs over classes? Well, you guys probably already know that struct does not provide any inheritance. What does that mean? Well, we've taken a look at this. Some of you guys are very overwhelmed by this, but this is iOS framework, right? They follow object-oriented programming, so they have a lot of classes and a lot of inheritance going on, UI view, UI control. But when it comes to struct, you're not allowed to build this pyramid. You're not allowed to build this infrastructure. Everything will be flat. But why is the benefit? Well, let's say you're working at Apple for the first time as an intern. A very nice position. Wish I could work there. What happens is when you are working with UI button, what happens is you brings everything from UI control, UI view, UI responder, UI NS object. So even if you kind of try to change something UI button, you kind of get everything on top of them. Of course, I'm talking in a very higher level, abstract manner. But when it comes to object-oriented programming, things can get very, very bloated. Because when you're working with UI slider, you have to get everything from NS object. They have references, and they have like relationship all the way from the top. Okay, so when it comes to object-oriented programming with classes, things can get very, very hard to navigate and also hard to refactor. Because when you try to change something in UI view, it's not only going to affect what's on top of the bottom, it's going to affect the UI image view, UI table, so it has a very tight connection between classes and subclasses. So it becomes hard to navigate. Well, and also it's about based on according to the Stack Overflow answer. By the way, the references are all available in the lecture notes, so go there, take a look at this. They're 10,000 to 1 million times faster than classes. Somebody did a benchmark. Well, because when it comes to struct, there's no any inheritance. What happens is simply you're taking the value out of it. Just like it's like a copy paste. Like, what's the value? Okay, good. But when it comes to object-oriented programming, if you're to work with UI switch, you have to get every single code. The computer has to go through entire thousands of lines of code from UI control, UI view, responder, and NS object, and much more. It becomes much slower. But as you know, phones these days are super fast, so it doesn't really matter that much. But still, if you're working with server, value type can get useful. So also mutability, there's no mutability when it comes to struct, no mutability due to no relationship between object. So this is what I mean by that. So because when you're sharing this object in memory, what happens is when you are working with human class object, let's say theoretically, you can simply change the human class property here. But what happens is, let's say your teammates is also using the same object, okay? But they like, oh, what has happened to this class? What happened to this object? They may face some sort of a problem that they may not be expected, because you've changed something from while working with this object. You've changed it working with this instant. You've changed something to this object. So what I call a mutability, because you're sharing the object. So one can change the object, so it can cause a different huge problem later down the road. So when it comes to bigger project, it becomes unmanageable. So these days, Swift is actually struct-oriented programming. So if you take a look at classes, if you take a look at string, we've taken a look at before, int, array, they're all structs. They don't share anything. Well, sometimes they do, but most of the time it's a struct, protocol-oriented programming. So you're going to find a lot more about value type when it comes to writing better, scalable, and also, what do you call that? Just amazing Zen, right? That's the right word. Zen code, okay? Non-nested structure. It's flat. It's amazing. Well, we're going to learn a lot more when it comes to protocol or programming with me, with enums, generics. It's going to be a whole different world. So I've also attached references to take a look at. If you are a couple dissing the object or programming, so if you can take a look at it. If you're subclassing it, you are doing it wrong. But all Hector methods and all evidence points to object or programming is bullcrap, right? Sensor. And also object programming is exceptionally bad. Like, people kind of don't like object or programming because nobody wants to work with this kind of code when if you want to work for a company. Okay, so it becomes very hard to navigate. That's why Swift is amazing. There's no well, I'm talking a very higher level of abstract, but as long as you understand the concept, the difference between classes and structs, and you understand what reference type can cause problems, and also is slower, then you've achieved this, the purpose of this lesson, and you're gonna find value type. You're gonna learn more about value type along the way. Okay, so see you guys in the next lesson. Keep coding. If you have any questions, comment down below. I'll be right there to help you guys out. See you. Bye bye. Boom, you've learned the fundamental difference between classes and structs when it comes to creating objects. Instances that are created with classes has a reference to that object, while struct simply has its own memory address, or simply store. At this point, you may not find the incentive to learn about the difference between value type versus reference type. Yeah, when you're making a small app, such as making a flashlight app, it doesn't really matter. But when you're making something a little more complex, such as closures, delegates, you will encounter a little problem with reference type. Well, you will discover those problems in chapter 5 and then understand why value-oriented programming, such as functional programming, protocol programming, are rising to the top. You'll also learn about those later in chapter 6 and afterward. Well, there's a long way to go, right? But I believe in you guys that will get there eventually. See you guys soon down the road.